Now that we've worked with variable expressions in various ways, for example, applying the distributive property, working with positive and negative integers, and combining like terms, we're going to dive into our next objective. Students will be able to solve equations for a missing value using the O.I.R method and inverse operations. So let's go ahead and review how to solve a multi-step equation using inverse operation. Now we know that our method is the O.I.R method. So we start with the operation by identifying the operations that we need to apply. Then we need to identify the inverse of those operations, and then lastly apply those operations in reverse order. So the first thing that we need to do is identify what is the x, or the variable, in our expression. So here's the x. We ask in proximity what is the first thing we do to our variable. So in this case, we are multiplying by 10. After we multiplied by 10, we subtracted 4. And then once we are done subtracting by 4, we divide by -8. So then we can go on and do the opposite, which is the inverse of each of those expressions. So divide by 10, add 4, and then multiply by -8. And then we know that we need to apply those operations in reversed order. So we start off by multiplying that -8, then we're going to add a 4, and then we're going to divide by 10. So let's go ahead and see what that looks like when we apply this equation to our answer. So now that we have a clean slate, let's go ahead and apply that multiply by -8. So when we multiply both sides, remember we need to balance the equation. Multiply both sides by -8. Once, if we take a value and then we divide it and multiply it by the same exact quantity, we get what we started off with. So we get 10x minus 4. Then we have equals 8 times -8 is -64. Our next step is then going to be adding 4, like we just decided in our O.I.R method. And then we are left with 10x because +4 and -4 cancels out to 0. This is going to be -60 because a -64 and a +4 gives us a -60. And then we're going to close out by dividing both sides by 10. So we get an answer of x equals -6. So let's go ahead and explore what does this equation look like when we combine some of the concepts that we've learned. So we have a different looking equation, but we can solve this by thinking of how can I combine like terms. I see that there are an x in multiple places, so that means I need to do some combining. And I see that there looks to be a leading factor that needs to be distributed to terms inside. So let's go ahead and solve this equation requiring the distributive property. So let's go ahead and distribute that leading factor of -4 inside our parentheses. So when we write this as -13 equals -7x. -4 times -6x is going to give us a +24x. And then we are going to distribute the -4 with the -18, which gives us a +72. Once we have arrived at this part of the equation, we can then go ahead and combine like terms. We notice that we have x's and more x's, so we can go ahead and combine that. So this is going to give us a +21x, and then we leave with the constant of 72. So once we get to here, when it's just now a two-step equation, we can just apply the O.I.R method. So why don't you go ahead and solve for the value of x using O.I.R. Ask yourselves what is happening to the x, which is the variable, and then in order to solve for it, we need to apply the inverse operation, but we also need to apply the inverse in reverse order. So take a moment to solve for what x equals by applying the O.I.R method. Alright, let's go ahead and try a whole new problem. Again, in this situation, we need to apply the distributive property. So this means we have to distribute these two terms. The leading factor is a positive 8, and then we have two terms inside. So this stays the same because nothing changes about it. This is going to be a negative 40k because a positive 8 and a negative 5 gives us a negative 40. And then positive 8 and a negative 4 is going to give us a negative 32. Again, once we get to this part, it's now just a two-step equation that we can use the O.I.R method. So I'm just going to go ahead and solve this by adding 32 to both sides. So that gives me 240 equals negative 40k. And then in order to close this out, I'm going to divide both sides by negative 40. This negative 40 on top, on the bottom, with the identity property, change this to a 1. 41 times k is going to leave me with k, because the expression negative 40 over negative 40 is just 1. 1 times any expression is going to be itself, so it's going to be k. And then 240 divided by negative 40 is going to give me a negative 6. So the answer to this problem is k equals negative 6. I have one last type of problem to introduce to you before we go and practice on our own. And that's an example on what if we have variables on both sides of the equal signs, on both sides of the equation. So we have an m on the left side and we have an m on the right side. But it's a good thing that they're both m's, because when we have like terms, we can just move them around from the left to the right or the right to the left by making sure that we keep our equation balanced. And the way we do that is just like constants, regular our counting numbers and our integers, we can add variable and add or subtract variable expressions as long as we make sure that we're balancing it out. So in this example, we have a negative 3m. So let's go ahead and get rid of the negative 3m on that side by doing the opposite, by doing the inverse. So I'm going to add a 3m. But we know that all good math needs to be balanced, so we need to apply the addition of the 3m on the other side of the equation. So now I have a problem of negative 55, because this negative 3m, positive 3m becomes a 0, equals 77 plus 11m, because if I have 8 m's with another 3 m's, I'm going to end up with 11 m's altogether. So then I'm now going to solve this two-step equation using O.I.R. My m is my variable. I ask myself what is happening to that variable. I multiply by 11 and then I add 77. So once you apply the inverse in reverse order, you should get a value for m. Give you a moment to think about what that answer is. If you solve this problem correctly, you should arrive with an answer of m equals negative 12. Let's go ahead and try a problem together using the same concept. We have r's on both sides, so what we need to do is we need to make sure that the variable only shows up on one side, so we pick a side to move the other r's to. So let's say we want to keep the 4r on the left. That means we have to get rid of the 2r on the right. So if we're adding a 2r on the right, in order to get rid of it, we need to minus the 2r, but we need to balance the equation by doing the same thing on both sides. So if I have 4r minus 2r, I get 2r. The 30 stays the same, equals negative 18. Once I get to this step, it's just another two-step equation, and I'm applying the O.I.R method. So let's go ahead and complete this out. I'm going to subtract 30 on both sides now. Once I subtract 30, I then have 2r equals negative 48. And then closing out by dividing both sides by 2. So the 2's cancels out into a 1. 1 times r gives me r. Negative 48 divided by 2 gives me negative 24. So I've gone over two types of problems. Problems where I have to distribute using the leading factor and distributing throughout the variable term, the polynomial, and then combining like terms. So that was the first type. The second type, when we just went over, is making sure that the variable only shows up on one side. So we're isolating variables to one side by making sure that we're applying the inverse of the variable to both sides, balancing the equation to create a whole new two-step equation. Once we reach the two-step equation, we can then go ahead and just apply regularly the O.I.R method. So finding what operations are being applied, the inverse of those operations, and then solving by applying the reverse order. So take a look at this problem. H plus 55 equals negative 143 minus 10h. This looks to me like a type 2 problem where you need to isolate the variable to one side. Have a look at it and see what you come up with. Once you're finished with this problem, I would like you to take a challenge and see if you can solve this problem where I throw in a fraction form. Now this looks a lot more complicated, but really isn't, because now we're working with multi-step equations. Apply what you have learned so far and see if you come up with an answer. Good luck!